Hello students, in the previous video we studied about mass and then we differentiated with weight. What is mass? Mass is the amount of substance or quantity of matter in a body, and we said weight is the mass multiplied by the gravity. For example, gravity is that of a big objects like you have earth, sun, moon. So mass into gravity. And also we studied that mass does not change, but weight varies because gravity changes. And mass is measured using a beam balance and weight is measured using a spring balance. And then mass is measured in kilogram or in gram, whereas weight is measured in Newton, or simply we can say kilogram weight. You should remember 1 kg weight is equal to 10 Newton or 1 kg force. Some people will say kg force is equal to 10 Newton because gravity of the earth is 10 Newton per kilogram. So these are the basic things we studied. In this video, we are going to study about another concept called density. Density, dense. An object is heavier or lighter. And what does that mean? If a body is lighter, for example, cotton bale, you take cotton bale, it is very light. And when you take, for example, an iron ball is heavy. On what basis we say a body is lighter or heavier? And that is what we are going to study in this video, right? So let me take it slowly and steadily, each by part we will learn. See, I will first introduce a concept called volume. Volume. Now, what is this volume? Volume is space occupied by a body. Space occupied by a body. For example, this room is there. In this room, I don't see anything other than table, desk, fan, board, all that stuff. Other than that, invisible to me, air is there. So air is a matter, gaseous state. It is occupying this room. So the air occupying in this room, how much volume of air is occupied, we can find out. So volume is basically space occupied by a body. Space occupied by a body. Very simple. Let us take, for example, this duster. What is the volume of this duster? You should know the shape of this duster. The shape of this duster is more a cuboid. A cuboid. A cube is one in which all the sides are equal. You see, this is going to be a cube where all the sides are equal. It is a three-dimensional object. Three-dimensional, okay? This is one side and this is one side and this is one side, okay? But this is a cuboid, we can call it, because it is having rectangular shape like this and another rectangular shape like this, fine. And then it becomes a three-dimension, right? Back and front and everything is there. So this is the length and this is the breadth and this is the height. Length, breadth and height. So this is the volume. In this case of a cube, the volume is equal to side into side into side. Our volume is equal to a cube, where a is equal to side of the cube I have taken. But in this case, this is going to be a cuboid, I can say. In the case of a cuboid, volume is equal to length into breadth into height. They are different values. Volume V is equal to LBH. So let me calculate what should be the volume. Volume is space occupied. Mass is amount of substance, the amount material in it, space occupied, how much space is it occupying, that can be calculated by length, breadth and height. So how do we measure it? I am going to take a scale, and using the scale, let me measure the length. Okay, I will take it this point and I will take this next point. It is 14. Length is equal to 14 unit centimeter. Unit is important, right? Let me measure the breadth of it. That is 4 centimeter. Breadth is equal to 4 centimeter. Then let me measure the height of it. Let me see. This is 3 centimeter. Height is equal to 3 centimeter. So using this data, I can calculate the volume of the duster cube. This is a cuboid. Okay, let me erase this part and do this numerical and see how it works out. Okay, volume is equal to L into B into H. That is equal to 14 multiplied by 4 multiplied by 3. That is equal to 14 multiplied by 4 3s are 12. That is equal to 14 multiplied by 12. 4 2s are 8, 2, 4, 1. Okay, 8, 6, 1. 168. Now, what is this 168? What is the unit of this? Volume is equal to 168 centimeter into centimeter into centimeter, centimeter cube. Centimeter cube is the unit of it. If it is in meter, the answer will come meter cube, or sometimes people will say cubic meter or cubic centimeter. Both of them are one and the same. Cube, because 3 values are there: length, breadth and height. So it is cube. Now you may wonder, for solid, okay, you can measure using a scale and you can measure. And in the case of let us say liquid, how can we measure the volume? How can we measure the volume of a liquid? So for example, I have got a beaker here. Now a beaker which I have taken here is 500 ml. It is a beaker like this, okay, a small tin there, okay, fine, let me draw it like this. Yeah, in this beaker, okay, it is written 500 ml, 500 milliliter, okay. It starts from 0 here, okay, and it is 100, 200, 300, 400 and 500. Now I take the liquid, very simple liquid, water. You take water and you measure till this 500, and that is the space occupied by the water. The space occupied by the water is 500 ml, and we say that 1 ml is equal to 1 cubic centimeter. Okay, this you can learn later. 1 ml is equal to 1 cubic centimeter, right? And 500 ml will be equal to 500 cubic centimeter. We can convert from liquid to solid value, that is centimeter cube. Now you also can use a measuring cylinder. A measuring cylinder, a tall measuring cylinder which you will see in your lab and all, right? In a chemistry lab and the physics lab you can see, right? And it also will have a small beak like this, right? And it will have a small beak like this, and then it is graduated. Maybe 100 ml, you can take it, 1000 ml you can say, right? In the middle it will be 500 ml, okay? And it will be here 0 ml, okay? You start from 0 ml, 100, 200, 300, 400, 500, then 600, 700, 800, 900 and 1000 ml. You can take water in this, and 1 liter of water. What is 1000 ml? 1000 ml is equal to 1 liter. 1 liter. You purchase oil. For example, you purchase sunflower oil, right? Sunflower oil packet, you see, they would have written 1 kilogram oil, you say, that is 1 kilogram, and ml, a little different value will be there. So 1 liter oil, you purchase it in the packet, right? Or for example, milk packet is there, right? Milk packet, you see, half a liter milk, you say, or 1 liter milk, you say. So these are all measuring the volume of a substance. So what is volume? Volume is the space occupied by a body. For air, whatever the shape of the container, and it will have the same thing. Okay, fine. Now I also will give you an example. I will give an example for gas also. Then you will get an idea how all the matter can be measured. Okay. For example, let me erase it. For example, I take a hot air balloon. Let us take a balloon. Okay. Forget about hot air balloon. Balloon is closed here. We know this balloon, how much it is going to contain. Let us say we don't know. So what we do, we fill air with it. So air, it is filled. Now you see, how much volume of air is this balloon now containing? How can I calculate this? How can I calculate this? It's very difficult, right? Unless and until, suppose I have a balloon and in this balloon you can blow this much big, or somebody else blows it little bit more big, or somebody else blows it much bigger. Then in each one the volume of air will be different, right? In the small one it is less volume, and in this it will be more volume compared to each other. So how do we measure how much is there? Volume, how can we calculate? I will tell you that a little bit next step of this video. So now I hope, dear students, you understood what do you mean by volume. Volume is space occupied by a body. Space occupied by a body. So we know two things now clearly. One is mass. Mass is amount of substance or matter contained in a body. And we know that volume is space occupied by a body. We know these two. Can we relate these two together? And that is called density. What is density? Density is equal to mass upon volume. Mass upon volume. Okay, this is called density. You know mass, space occupied by a body. Volume, you know that. So what I'm going to do, I'm going to take this duster, right? In this duster, see, again I'm drawing the duster for you. Okay, see, just watch carefully. Duster. How do I measure mass of this duster? I measured it using a beam balance, and I got the value of the mass of this duster to be equal to 120 gram. This is what I got it, right? I already measured in the physics lab using a balance, and I got this to be equal to 120 gram. Now I measured length, breadth and height, and I got the volume. This is mass of the body. Okay, let me write capital M for you, and volume is equal to, just I remember 168 cubic centimeter, if I am not wrong. Please check it. 168 cubic centimeter. Why I remember? How do I remember 168? You know, I will tell you. I know 169, that is equal to 13 13s are 169. So I thought it is coming 168, one number less than that. Oh, this is square of 13 and 13. This way we can remember easily with the numbers, right? So 168 cubic centimeter. Okay. Now I want to calculate density. Density is equal to formula mass upon volume. What is the mass? 120 divided by 168. Okay, this is gram and this is cubic centimeter, right? You say gram per cubic centimeter. What is the unit of density? Density is the unit is gram per cubic centimeter or kilogram per meter cube. Anyone? Yeah, it is for bigger unit. This is for smaller unit. Now we will try to calculate it. It's going to be a little difficult. You know, number is a little bit different. Okay, fine. With the 2 we will try. 60 times. Okay, with the 2, 80, 10 to 16, 84 times. Again we will try 4 times 2, 42, and this will go 30 times. And again try 15 times, and this will go 21 times. So I got here 15 upon 21, which is equal to. We need to solve it, you know. So that is very important. We solve it. I hope whether you will be able to see it or not. 15 here, 21 here. Okay, it will not go. So point. Okay, 150 it will become 6 times 6 to 7. Okay, 7 times 7. Okay, and 14. 7 times 7 and 14. 147 and 3, 30. We can say 1. So answer is 0.71 gram per cubic centimeter. This is the density of wood. You know, density of wood usually is 0.7, 0.8. Do you know? That is why wood floats in water. Wood floats in water. Why? Density of water is very special. Density of water is equal to 1 gram per cubic centimeter. Each substance has different density. Okay, each substance has different density. I am going to show you how, and then we will continue with that. Okay, so you understand, mass is the amount of substance or matter contained in a body. Volume is the space occupied by the body, and density is mass per volume, which has 2 units, gram per cubic centimeter and kilogram per meter cube, and density of water is 1 gram per cubic centimeter. 1 gram per cubic centimeter. Okay, now what I am going to do here, density, again I am writing this because our whole topic discussion is density. Density is equal to mass upon volume. Mass upon volume. D is equal to M upon V. Right? And I say gram per cubic centimeter, which is equal to 1 gram per cubic centimeter is equal to 1000 kg per meter cube. Come on, you just to learn it. When you come to higher classes, you will learn about how to convert it. Right? Now don't worry about it. Just to learn the equation. How is it? We know this much. Now, what I am going to do, 1 cube I am going to take. You know, cube is having equal sides. All the sides are equal. I have taken a cube. 1 centimeter, 1 centimeter, 1 centimeter. So, volume is equal to 1 cubic centimeter. Right? 1 centimeter cube. Now, I am going to take some substances, like let us say water. Okay, what I am going to do? I take 1 gram of water. 1 gram. You know, 1 gram is equal to 1 ml. Okay, in this way we will take it. I pour this into this cube. It's a hollow cube. It's like a small hollow cube, that small cube. I put 1 ml of water or 1 gram of water. You know that density is equal to mass upon volume. For water, density of water will be, mass is 1 gram divided by, this is 1 cubic centimeter. So that is 1 gram per cubic centimeter. Okay. Now what I am going to do, I am going to take for example mercury. You know mercury? Not the planet. The mercury, silver, shiny type. Yes, I take mercury. The density of mercury, you know, density of mercury is equal to, cubic centimeter. In 1 cubic centimeter, how many grams I have to put? We will find that you put 13.6 gram of mercury. 13.6 gram of mercury. If you put it, so the volume will be 13.6 gram per cubic centimeter. That is the density. Now, take same 1 gram, right? I take a cube. I cut this cube. Cube is made up of aluminium. You know that density of aluminium. Aluminium. That is equal to, aluminium is 2.7 gram per cubic centimeter. Right? We can go on calculating. Take another cube, cut it. For example, iron, we will take iron, steel, iron. Density of iron is equal to 7.9 gram per cubic centimeter. Okay, so this is how we calculate. Each substance has a different density, right? And they all depends on how much molecules or atoms are occupying in the given space, and that is what you call density, mass upon volume. Dear students, I am going to ask you a question. I am taking 1 kilogram of iron. Let us make a comparison. With that, we will complete this concept of density in this video. Fine. Let us see carefully. I take 1 kilogram solid iron mass, iron ball. This is iron. And I take 1 kilogram of cotton. Cotton, I am taking 1 kilogram. You see, cotton will occupy this much space, and this is cotton, and it is 1 kilogram. Yes, dear students, carefully watch this particular concept, then you will understand the concept of density better. See, 1 kilogram of iron is small. What is less? Volume. It is having less volume. And what about cotton? Large volume. Volume is more, and the volume is less. But what is same? What is same? Kilogram. So what is same? Mass is same. Same mass. Both of them are having same mass. But volume is more. Why is it occupying more volume? Why is this cotton is having more volume? Now, connect with the density, because density of iron is 7.9 multiplied by 1000, right? Multiplied by 1000 kg per meter cube, or simply 7.9 gram per cubic centimeter. This is heavy. It is heavy. But cotton is loosely packed, and mass is same. Density is equal to mass upon volume. Mass is same, but more the density, less the volume. More the density, less the volume. And cotton, what is the density of cotton? 0.6 gram per cubic centimeter. 0.6 or 0.7, you can take it. This much is that of the cotton. So, less the density, more it occupies the space, more the volume. Yes, so you can understand an object is heavier or lighter. It depends on density. That is why wood floats and a stone or iron sinks in water. This we will see in our next class. Thank you so much.